Okay, so open that one up. I'll give you a minute to get there. Okay. So we are supposed to find the average value. Okay, so that's a big key. Those are some big key words there, right? Of this function, f of x equals e to the negative x on the interval from 0 to 2. When I see average value, what does that mean I have to do? It's not average rate of change, right? It's average rate of change is slope. What's average value? I'll give you that much of a hint. 1 over b minus a. What's my b? 2. What's my a? 0. And I'm integrating from 0 to 2. And then I'm literally integrating this thing here, e to the negative x dx. Okay. All right, so I have a 1/2 in front. Actually, I may change those. We'll see. I don't know. I don't know if I'll change them or not. All right, what do I need to do to integrate that? There u sub right there. So u equals negative x. Du equals what? Negative dx. So what do I need to add in? A negative in the front, a negative inside. So there needs to be a negative in there. I could probably ignore it other than that, right? So I'm going to go ahead and keep the 0 and the 2. And I'm just going to keep the e to the x part. We've got a negative inside. So really it's just adding a negative to the 1/2 out in front. All right, when we integrate this mess here, when we integrate e to the x, what do we get? And we're going to use the negative x, right? So whatever was in there. So negative 1/2 e to the negative x, and we're going from 0 to 2. I shortcutted a lot there. If you need to go back to the subbing in the u and underlining the blue and the orange part, that's fine. Okay, totally okay. All right. I am going to, I feel like there's something wrong with my negative there, but okay, let's see what happens. We're going to put in the 2 and the 0. Oh, I know what might have gone wrong. Okay, so we've got negative 1/2 e to the negative 2 minus negative 1/2 e to the 0, right? Okay, what happens with the double negative? Positive, good. Okay, is this e to the negative 2 happy where it's at? No, so I'm going to move it downstairs. And then this piece back here, e to the 0 is just once, it's going to be plus 1/2. Let me make that look a little cleaner. So it's 2e squared. Now, that is none of our answer choices. Okay, so I have to get to one of my answer choices, which means I'm going to probably need a common denominator. Okay, so what is my common denominator going to be? Good, 2e squared, right? If I have to go back to algebra 2 with trig, right, I don't know, what do we circled in red what matched, wrote it once, underlined in blue what didn't match, wrote all of it, right? That was way back to algebra 2 trig. Okay. All right. I'm missing nothing here, right? So that's just a -1. What am I missing in this one? E squared. So technically I'm multiplying top and bottom by e squared, so plus e squared, and then it looks like I just need to reverse the order. So my guess is you may have gotten it close, and then the algebra probably, the multiple choice algebra may have thrown you off at the end. Okay. All right, make sure you write down what you did wrong. Give you a couple seconds to do that, and then we'll try see if we can squeeze in part of the next one before the bell rings. Okay. Oh, this one shouldn't be bad for us to do. We should definitely get this one in. All right. Tockwitz Varsity Calculus Class of 2023 eats pie over a 7-day period. The pies ready for consumption are stored in a super secret temperature regulated pie storage container, also known as the math department refrigerator. Shh, don't tell anyone. There is a refrigerator out there, by the way. 3rd period kids asked me. Pies are put into the storage container, and the number of pies in the container is modeled by a strictly increasing twice differentiable function p, where p of t is measured in the number of pies and t is measured in the number of days. At time t equals 0, there are 10 pies in the storage container. What's that called right there? That's your initial condition. Which of the following best expresses the meaning of 1/7 from 0 to 7 of p of t dt equals 6 in the context of the problem? What does that right over there, over that mean? That's average value. So when we're talking about average value, it should say something about the anything but rate of change and the word average after it. So probably average number of pies is probably what we're looking for. So let's see what happens. All right, so in A it says average rate of change. That's automatically out because we know it's not average value. Okay. This one says average number of pies. So I'm going to keep that in. Let's see what else we got. Total number of pies. Is that average number of pies? No. That one says rate of change. That one's out. Look, I didn't even need to know the whole rest of it. All I needed to understand was the 1/7 meant average value. Okay. I think a lot of us did okay on that particular one. All right. I think that's as far as we're going to. I think that gives us one more to do tomorrow, right? But it's still got a lot of parts to it because it was the particle motion one. So come in ready to do particle motion. Again, you may use your graphing calculators tomorrow for this quiz. You can use the graphing calculators for the re-quiz on the other one on Friday too. Okay.